Hi, this is Craig Stocks for Utah Desert Remote Observatories. You can find us online at utahdesertremote.com. And I'm doing this video in two parts. And you'll be able to go to the website and go to the blog section, and you'll find a blog post with this information, some additional information, some links to some of the things that I've talked about, as well as the two-part video that I'm going to record here. So what this is about is using a layer-based, non-destructive workflow in Photoshop. It's what I call a better way of working. By staying with a layer-based and non-destructive workflow, I think you'll find it's fast, easy, flexible, and all those things yield better results. And the advantages of a layer-based workflow are, first of all, as I mentioned, it's fast. No need to edit individual channels, which is a destructive process. In other words, you're actually changing pixels, and we want to try to avoid changing pixels whenever we can. There's no need to use some of the advanced tools like calculations or apply image, and it really lets you edit visually rather than numerically. So you can move sliders, watch the change, and visually kind of migrate towards the result you're wanting to get. It supports adjustment layers, which are really the key to non-destructive editing. The advantage is that you can continue making changes even after you save the document. You can reopen it and go back to any of the creative decisions that you've made along the way and make changes. That's as long as you don't flatten the image or merge the adjustment layers into a pixel-bearing layer. So if you keep your layers intact and save with the layers intact, you have those advantages to go back in the future. It makes star extraction real simple and powerful, especially with a tool like Star Exterminator that runs as a Photoshop filter, and you can run that on individual layers within the document. And with narrowband images especially, I like to extract the stars for each color or for each element individually. It allows you to easily kind of mix and match the data multiple different ways for RGB, HOO, SHO renderings of narrowband data, and so forth. And lastly, it lets you easily add additional data if you go back to the same target in the future. So what we're going to do, we'll work with an example that I imaged at the observatory at Utah Desert Remote Observatories. And this was done with the Takahashi FSQ 106. And the sequence in Voyager that I set up, I used hydrogen, oxygen, and sulfur, and I did those subs at 600 seconds each. And then I also did red, green, and blue at 120 seconds each. So as that sequence ran, it produced a whole bunch of files, and I loaded all of those into Deep Sky Stacker and did the initial registration and chose the hydrogen with the highest score and used that as the reference frame for all of the stacks. And then I went through the subs kind of individually by filter and stacked each one of those individually relative to that same reference frame. And that gave me 6 reference groups from each time you run Deep Sky Stacker, you get an autosave.tiff file. So that gave me 6 of those. For the narrowband images, I also saved those as 32-bit FITS files separately. And the reason I wanted those as 32-bit FITS files is so that I could stretch them somewhere other than in Deep Sky Stacker, because stretching is not the thing that Deep Sky Stacker seems to do best. So for that, I loaded the 32-bit narrowband FITS files into a program called FITS Liberator, and it has a lot of different stacking algorithms, but the one I liked here is the arcsine H, which is inverse hyperbolic sine. That gives you a real nice stretch with the ability to bring out detail in the dark areas without overly stretching the bright areas. You do have some controls where you can adjust on the histogram the black level and the white level. I tend to do it just visually, and then from there I save these as 16-bit TIFF files. So when I'm all done, I have 6 files to work with. I have red, green, and blue as unstretched autosave.tiff files, and those are a 32-bit format. And then from Fitz Liberator, I have the narrowband files as 16-bit TIFF files, and those have already been stretched. So from those 6 inputs, we can combine the best of all of these into one output result. And we're going to do that live, and we'll actually do it in 2 steps. The first thing we're going to do in the first video, we'll take all of our red, green, and blue and load those 3 files and do what I consider a hard stretch to create this base image. And then from that, I'll extract the stars using Star Exterminator. Then we'll load those same red, green, and blue a second time and do a light stretch. And you can see there's a lot more detail in the core with the light stretch, and the stars are smaller and hard to see here, but they retain their color. So from that, we'll remove the stars again to create a starless version, and then we'll subtract to create a star-only layer. So that will give us a star layer and a starless light stretch layer. We can combine those with that original base to create a little bit better version of it with small stars instead of large stars, and with a little more detail in the core area that we brought in from the light stretch. In the second video, we'll venture into the narrowband files. We'll start by combining the narrowband images and creating an HOO version. We'll also create an SHO version, the sulfur, hydrogen, and oxygen, which is the classic Hubble palette. Pretty green with Orion because of all of the hydrogen. We can subtract the stars from that, again using Star Exterminator, and then we can drop that underneath our nice small RGB stars to create a narrowband image with RGB stars. We can also go back to our original core and start to bring in some of the goodness from the narrowband images. For instance, we can bring in some of the oxygen in the area around the outside of the Orion Nebula. We can also bring in some of the hydrogen that shows up in the background, and we can even use some of the sulfur data to bring in a little more detail in the bright area and around the trapezium. And I'll do the kind of the final edits and color balance within Photoshop, save it at this point as a PSD or a PSB if it's greater than a 2 GB file, and then load that into Lightroom, where I'll do the final color and contrast adjustments, any local contrast that I want to adjust with texture or clarity. And this is where I would rotate and crop the image, because I don't want to crop the image until I know what size I want it and I'm ready to use it. Because I may want this as a horizontal 16:9 for a wallpaper on my computer. I may want to print a 16:20 vertical. All those are different sizes and different aspect ratios. So I don't want to make those decisions until the very last minute. Also, by not cropping along the way, I'm still free to mix and match and add files in or take files out and move freely between the different versions because nothing has been cropped. So with that, let's go to Photoshop and get started. The first thing we need to do is load the red, green, and blue, and to do the hard stretch I want to load these just as individual files. So I'll just go to Open and navigate to the folder where those are located and just choose red, and then I can control click to choose the green and blue also. Click Open, and that'll open each one of these as its own file in Photoshop. And because these were saved as 32-bit TIFF files, we need to do 2 things. We want to apply a hard stretch, and we want to convert it from 32-bit to 16-bit. Well, it turns out there's a slick way to do that all in one step, and we'll start with the red. If I go to Image, Mode, we can see it's an RGB color image, which is good. That's what we want for color. But it's a 32-bit, and we want it to be a 16-bit. So I'll click on 16 bits per channel. And then under the mode, I'm going to choose Equalize Histogram and click OK. And that will process this from a 32-bit to a 16-bit and do that kind of a hard stretch. Then we'll go to the green file, and we'll do the same thing. We'll go to Image, Mode, 16-bit per channel. We'll choose Equalize Histogram and click OK. And you can see it's kind of bloating the stars and maybe blowing out the core a little bit, but it's giving us a good starting point. Last, we'll go to the blue file, go to Image, Mode, 16-bit per channel. You've probably already guessed we're going to choose Equalize Histogram and click OK. And now, because we have done our stretch, now we can rename these layers to be a little bit more representative. That if I had renamed the layer first, it would not have given me that option for doing the hard stretch when we converted from 16-bit to 32-bit. So I'll just label each one of these blue, green, and come back to our original, and we'll just label it red so it's easy to keep track of. Now we just need to move our green and blue on top of the red. To do that, I'll just activate the Move tool, which is the top tool in the toolbar, or I can tap the V on the keyboard for Move. I want to click and drag this image up to the Destination Folders tab, and then continuing to hold the mouse key, drag back down into the image, press and hold the Shift key to let Photoshop know that we want to drop this in the same place that we took it from. Let go of the mouse, let go of the Shift key, and we have our green layer on top of red. I'll just do the same thing with blue, drag, move into the image, Shift, and drop. So now we have blue, red, and green all lined up. To keep organized, it would be useful to put each one of these in its own group, which we can do by just targeting the layer and using the Control G for a shortcut. And that can be useful if we want to make adjustments to each one of these layers individually without affecting the others. For this point, we'll just move ahead. I'll go to the blue group, and if I go to Layer, Layer Style, and Blending Options, it'll bring up a dialog box. And the interesting thing here is the dialog box has red, green, and blue with a check mark in front of each one. Well, since we only want blue from this layer, we don't want red and green, I can simply turn off the red and green and leave just blue. Then I can go to the green layer, choose Layer, Layer Style, Blending Options, and as you probably already guessed, since this is the green layer, we'll simply turn off red and blue, and voila, automatically we have red, green, and blue in a red, green, blue image. Now it'd be real tempting at this point to just flatten this and call this a red, green, and blue image. And that's not terribly bad because we really haven't made any creative decisions at this point. And we could just go through this process again and recreate this exactly as it is here. But since this is about non-destructive workflow, let's do something non-destructive instead. So instead of just selecting these layers and flattening them or merging them, instead let's go to Layer, Smart Objects, Convert to Smart Object. And it will take all of the selected layers and layer groups, and it will present to us a single layer that looks like it's been merged from these, but it'll have the Smart Object icon on it. And what that Smart Object icon does is let you reopen the individual source. So here it is as one group, or actually just one layer, but it's a smart object, and you can tell that by the little icon on the Layer tab. If I double click on the layer icon, it will in fact reopen that file as it was when I created the smart object, and there's my red, green, and blue. If I decide, for instance, I wanted to brighten up each one of these, brighten up the background a little bit, I could add a layer adjustment, such as a levels adjustment, and just brighten up the background a little bit on each one of these with a levels command by moving the black point up. Make it just a little bit brighter, and when I click close, it will ask, do I want to save the changes? I say yes, and it will save this and put this back into the smart object with those changes in place. So anytime I want to, I can revisit the red, green, and blue layers if I need to make adjustments. Sometimes you might find a satellite trail that you didn't notice going through one of the color layers. Makes it real easy to go back and adjust that again in the future. So now we're back to our smart object with those changes intact. And what we want to do next is remove the stars. And I'll do that with filter RC Astro Star Exterminator, but that takes a few minutes to run. So rather than running it here, I'm going to just close each of these, and we'll open a file where I've already done that. And I don't need to save any of this, so I'll just say no, close, no, and let me just go to File, Open, and we will open version number 1, which is the hard stretch, the smart object, and the smart filter in place. And lo and behold, there's our starless version. And if you look at the smart object, you'll notice that now below it, it shows the list of smart filters, and you can have more than one. And in this case, the only smart filter that we've applied is Star Exterminator. I can even turn that filter off, and that will reveal the stars. If I turn the filter back on, the stars go away. So we have a starless base image to work from. Now let's do the light stretch. So in this case, I do want to load these all into one file as layers. So I'll go to File, Scripts, Load Files into Stack. And this is a script that comes with Photoshop that lets you go find the files that you want to load. In this case, we want the red, green, and blue. Click OK. Click OK again to load those. And it's going to open up a new document, and it's going to load each one of those files into that document as a layer. It may come in with red on the bottom, then green, then blue. It may come in a different order, so we may want to change the order. Looking at it here, it's got blue on the bottom, then green, then red. And I always like to put blue on top, and I always like to put red on the bottom. So I have red, green, and blue. There's no reason that you have to do that. I just always do it that way so I can keep track of where things are in case I'm not very good about changing the names. So to stretch these, the first thing we'll need to do is let's check and make sure we're in an RGB mode. So let's look at image mode. We're at 32-bit and we are in RGB. Let's go ahead and change to 16-bit mode. And this time it will ask, do we want to merge this? And no, we don't. We just spent a lot of energy making sure that these were separate. So click Don't Merge. And it will convert this to a 16-bit image. And like we did before, we'll bring up the layer style dialog, which you can also get to by just double clicking in this gray area to the right of the file name on the layer. So double click there. That'll bring up this layers dialog. You might guess we're going to turn off red and green since this is the blue layer. We'll go to the green layer, double click, and we will turn off red and blue, leaving just green. The bottom layer is our red layer. It's contributing red, green, and blue, but we're replacing its green with this layer, and we're replacing its blue with this layer. So the end composite is a nice red, green, and blue. Now to stretch this, we do have to make some monochrome copies of the total result. So to do that, I need to stamp a layer that has all three of these represented, and the keyboard shortcut for that is Shift Control Alternate E. So basically the whole left side of the keyboard. That gives me this layer stamped as a layer. I need to remove all the color from it, so Shift Control U is a shortcut to desaturate everything, and then I'll just duplicate this, Control J, to give me one more copy of it. So I have two monochrome versions of the red, green, and blue. Now I want to do the stretch, and this is using the technique by Mark Shelley, and I'll have links in the blog post on the website at utahdesertremote.com. But basically what I want to do is simulate an arc sine stretch. So on the top layer, we'll target the top layer and we'll go to the blending options, and there's a lot of different ways you can blend layers or layer groups with what's below it. And in this case, we want to choose divide. Then I'll go to the layer below it, and I am going to drop it into a group with Control G, and I'll put this group in the multiply blending mode. So effectively what we're doing is we're multiplying by something, which is this grayscale image, and then we're dividing by the same thing, and if you multiply and divide by the same thing, you get back the original value. But I can now go inside this group, target the layer in the group, and we'll add a curves adjustment layer. And Mark Shelley also has where you can download some of these presets for the curve that simulate the arcsine stretch. And he actually wrote the arcsine stretch algorithm in PixInsight, and these were developed to emulate that as close as he could. So I'm going to choose the arcsine 100. These are just varying strengths of stretch. And that gives me a pretty good looking stretch. Now, one thing I do want to warn you, if you're zoomed out, it will look kind of ugly and pixelated and the colors won't blend correctly, but once you zoom in beyond a certain point, then it will smooth out and it'll show you the smooth result. The smooth result is always there, it just isn't always visible. So now we have our light stretch, we have good color in the stars, and the stars aren't bloated. We have some detail here in the core, and we want to do two things. First, we want to just preserve a copy of this that we're going to extract the stars from. So at this point, I'll do a Shift Control Alt E and create one layer. And then I'll remove the stars from that layer, again by going to Filter and the Star Exterminator. Again, that's going to take a while. So rather than doing that at this point, what I'll do is we'll just close this and we'll open the file where that's already been done. So let's go to File, Open, and we'll choose Step 2. Light stretch where Star Exterminator's already been run. That file is opening for us. And there we have it. So this has two things of interest for us. First, it has the starless layer, but it also still has the starry layer. And since we have stars and starless, we can subtract the starless from the star layer, and that will leave us with just the stars. So again, we can use the magic of blending modes. Let's choose the subtract blending mode. That leaves just the stars because that's the only difference between the star and the starless. Now again, we want to preserve this, and it's a little deceptive because right now we're seeing it only because we have a layer in subtract mode. So we'll do a Shift Control Alternate E to stamp that, and that will give us an actual RGB star only layer. And now we'll label this RGB stars only. And the layer below it, which is currently in subtract mode, we'll put back into normal blending mode, and we'll label this starless light stretch. But these give us two things that we can use on our original, because we have now some detail we can add to the core area, and we have some nice small colorful stars. So let's go back here. We'll select these two layers that have the stars and the starless. And again, we'll click, drag, move into the image area, hold the Shift key, release the mouse, and we've added that. So right now they're both in normal blending mode. I'm going to target the star layer, and I'm going to Control G to drop it into a group, and I'm going to put that group in linear dodge blending mode. And so that gives me just the stars. Now the layer below it has a lot of detail. In fact, it has probably more dark detail than we want because it's darkening everything, and we really want to just selectively darken some of this core area. So what I'm going to do is again add a layer mask. So I'll go to Layer, Layer Mask, Hide All, and that will create a layer mask that's filled with black that hides everything. But now I can target the mask, tap B for the brush tool, and with the brush tool active I can paint with white. Currently black is the foreground color, so I'll tap the X key to switch to white. It's painting at about 10% opacity, and as I paint with white on that mask, it will just paint in a little bit of that detail from the dark area. So that's before, that's after. I can turn the stars on or off. If I want to see it with the big bloated stars, I can turn this filter off, and there's the big bloated stars, there's the smaller stars. If you want to change the size of the stars, you can actually just come into this layer group and add, for instance, a levels adjustment, and if I adjust the brightness of those stars, I can make them a little bigger or smaller and kind of tweak those to whatever size I want. That is really the end of the broadband tutorial, so I'll leave it here, and in the next video we'll pick up here and we'll go add some narrowband information. We'll create an HOO and an SHO version, and then lastly we'll combine that narrowband data with this RGB version to create our final masterpiece. So thanks for watching up to this point. I hope you have a great day and an even better tonight under clear skies. Thanks for watching.